Hey folks, welcome to another lecture. Now we're getting into chapter 5, and the topic here is elasticity. I just will tell you up front, just to be honest, elasticity is not the most exciting and cool and fancy topic in the universe. But it's not that big of a deal. It's not hard, but it's so important for us to understand this as we go on before we use the supply and demand model in other contexts. We got to understand what elasticity is all about, but it's not the coolest topic of this whole course. Those cool topics will come later on when we get into, different stuff after we've established this baseline. Anyway, elasticity. I will share my screen with you, just as always, so you can see my cool notepad. First off, we're going to talk about price elasticity of demand. Price elasticity of demand. So we're talking about the demand curve and how responsive quantity demanded is to changes in price. We're going to talk about different elasticities later on, but we're starting off by talking about how responsive changes in quantity demanded is to changes in price. That's what elasticity refers to. So let's just start off by showing a few contrasting examples. First off, we're going to look at a demand curve that's relatively flat, right? Before, I've just drawn demand curves just however I took a notion to draw them. But now we're going to talk more specific about steep or flat demand curves. So this demand curve, as I've drawn it, it's relatively elastic. Relatively elastic. So if this is P1, the quantity demanded associated with P1 is Q1. If we drop price by a given amount, P2, then here's the quantity demanded. So this drop in price led to what I'm depicting, what I'm calling a relatively large change in quantity demanded. You see that? Right? We have a relatively small change in price on this axis. Over here, we have a relatively large change in demand, in quantity demanded correspondingly. So this is a relatively elastic demand curve. And that means that the responsiveness, right, how much quantity demanded changes in response to a change in price, is relatively large. The curve is relatively elastic. It's relatively responsive. On the other hand, here's a different demand curve. We'll start off basically at this same price, P1. There's the quantity demanded associated with P1. We'll put out a similar change in price, P2. Here's the change in quantity demanded, Q2. So we're looking at, just by looking at the graph, just by eyeballing it, we're looking at a relatively similar change in price, but over here we get a very, very small change in quantity demanded. This is a relatively inelastic demand curve. Inelastic, the change in quantity demanded isn't very large relative to that change in price. This demand curve, quantity demanded, is not very responsive to changes in price. Relatively elastic, relatively inelastic. We have other elasticities as well. Looking at this one here. Well, you can draw a really weird demand curve that looks just like that. For this demand curve, we think of it as, for a given price, for a price here, there's basically an infinite demand. People will buy however much they can of the good at that price. But if the price rises even just a little bit, demand is zero. This is perfectly elastic. At a given price, P1, people will buy however much. If price rises even $1, demand falls to zero. It's perfectly elastic. On the flip side, this is a weird demand curve as well. No matter what the price is, people buy this same quantity. This is perfectly inelastic. So we have a relatively elastic demand curve that's pretty responsive, right? Given change in price yields pretty high change in quantity demanded. We have perfectly elastic, where price rises even just a little bit, demand goes completely to zero. This is a weird case. I think this is just something we show for, this is something we just show for illustrative purposes. Nothing like this exists in the real world, but we show this for illustrative purposes. Over here on the other side, we have a relatively inelastic demand curve, where for a given change in price, we have a relatively small change in quantity demanded. And then here we have perfectly inelastic. People buy the same amount no matter what the price is. Price here, price here, price here, price here, price here, price here. People want to buy the same amount. I'll describe how we calculate elasticity in just a second, but for the elastic demand curve, we say the elasticity is greater than 1. For the inelastic demand curve, we say the elasticity is less than 1. These are an absolute value, by the way. Obviously, for demand, elasticity is negative because the demand curve slopes downward. As price goes up, quantity demanded falls. But we just calculated elasticity. It's an absolute value, so don't worry about the fact that it's actually negative. But here the elasticity is greater than 1 in absolute value. Here the elasticity is less than 1 in absolute value. Perfect elasticity, the elasticity equals infinity. Perfectly inelastic, elasticity equals 0. No matter how much the change in price is, the change in quantity demanded is nothing. The classic example that we give, just think for a second, I'll pause this video and think if you can think of something that would be an example of a perfectly inelastic good. Okay, hopefully you paused, hopefully you've thought of it. The classic example here is insulin. Right, people who have to have insulin, well, they have to have it. They die without it. So it doesn't matter what the price is of insulin, people are going to buy that certain amount that they need. Insulin is kind of your classic textbook example of something that would be perfectly inelastic in demand. I'm not going to bother to draw it, but we also have, just for completeness, we also have something called unit elasticity, and that's when the elasticity is equal to 1 exactly. Yeah, that's just, that's not important. That's just to complete the like list of possibilities here. I mean, in this class, we're going to be talking about relatively inelastic demand curves and relatively elastic demand curves, relatively unresponsive demand curves, or relatively responsive demand curves. That's what we're going to be talking about. But you see kind of all 5 of those to cover all the possible bases. We have the determinants of elasticity. You see that following in my notes, the determinants of elasticity. The first one is availability of close substitutes. Availability of close substitutes. I think it should be straightforward to imagine that the more close substitutes there are, the higher the elasticity for a given product. If we're talking about a specific soft drink, for example, right? You have Coke, you have Pepsi, you have Dr. Pepper, you have Mountain Dew, you have Fanta, whatever. If the price of one of those types of soft drink goes up, then consumers have a whole bunch of different options. They have a whole bunch of different things to shift away to. So there's going to be a relatively high elasticity. So if the availability of close substitutes goes up, that translates into a high elasticity. That should make sense, right? the easier it is to substitute away from a product that's increasing in price, the more people will substitute. That can be depicted, or that can also be thought of as just a relatively responsive demand curve. Next one is necessities versus luxuries. Wait. Necessities versus luxuries. The idea is for necessities, things that you have to have, there's going to be relatively low elasticity. Elasticity is low if it's a necessity. If it's a luxury item, you don't really have to have it. It's just something you're doing for fun. For luxuries, the elasticity is going to be higher because there's just so many more options for people to shift into with luxury items. Okay. The next one is just simply our definition of the market. And I mean, we're kind of talking about this in an absolute sense right now, but in the real world, a lot of this is ambiguous, right? I mean, what I'm giving you is kind of a way to think about these issues, but in the real world, you kind of have a lot of follow-up questions when you're kind of trying to calculate elasticity or think about elasticity. With definition of the market, with a more narrow market, if we're thinking about a particular good that way, a narrow market, we have relatively high elasticity. If we're thinking about a broad market, then the elasticity is relatively low. Just think about it this way. The elasticity of Coke is going to be relatively high because that's just one soda, and there's so many other sodas that a consumer can choose from. That's kind of an example I gave a second ago. But if we think the elasticity of all sodas, it's going to be a lower elasticity, right? Because you can't substitute between Pepsi and Coke. There we're talking about a much broader market. Does that make sense? The more narrow the market that you're thinking about, the higher the elasticity is going to be. But if we broaden out the market, we get a lower and lower elasticity. And then the last determinant is the time horizon. If we think about a market in a very short-term sense, right? Very short-term, the elasticity is going to be lower. If we think long-term, elasticity is going to be higher. Here, probably a good example is to think about the elasticity for gasoline. Right? If the price of gas goes from $2 a gallon to $5 a gallon, in the short term, there's nothing I can do, right? I can't move closer to work, or we can't put in public transportation, or we can't put in better bike paths. We're kind of stuck. There's nothing we can do. We just have to still continue to drive in the short term, even if the price of gas goes up to $5. So if we define the market to be just the short-term picture, then the elasticity is going to be higher. But if you think over a much longer time horizon, if the price of gas goes up, then we can develop alternatives over time. Like I said, people can move in closer to where they work. We can develop better public transportation systems. We can develop better bike paths. We can buy more electric cars, whatever. Over the longer term, people are going to be more responsive to a change in the price of gas because they have time to develop those alternatives. So in the short term, the elasticity will be lower. In the long term, the elasticity will be higher. I hope that makes sense. I just will say in your book, if you look in the latest edition of the ManQ book on page 93, you can see that ManQ gives like 8 or 10 different specific goods, and he actually provides elasticity estimates for those different goods. You can look at, for example, eggs. Eggs is a kind of, most people think of eggs, I think, as a necessity. They're a key part of the diet of many people. For eggs, we have an elasticity of 0.1. It's inelastic. The elasticity is less than 1, and consumers are going to be very unresponsive to changes in the price of eggs. Healthcare, elasticity of 0.2. Kind of same idea as what I said before with insulin. Healthcare, you have to have it. If the price goes up, too bad, you just have to pay it because you can't go without health care. Cigarettes, right? People are addicted to cigarettes. Price goes up. There's nothing they can do. They're addicted. They have that. They start freaking out or whatever if they don't have cigarettes. So cigarettes, relatively low elasticity. Rice, relatively low elasticity. Housing, relatively low elasticity. We get up to things like restaurant meals, right? With restaurant meals, we see an elasticity of 2.3. It's elastic. The elasticity is more than 1. Restaurant meals are a luxury, right? If restaurant meals become more expensive, then, well, we can start cooking at home more. That's a pretty straightforward idea. Mountain Dew, right? Mountain Dew, the soft drink Mountain Dew, elasticity of 4.4. If we have the market defined specifically as Mountain Dew has a vast array of alternatives or substitutes, so it has a really high elasticity. So our next topic is, I don't know how to work this software. I don't know how to scroll to another page. Computing price elasticity of demand. Computing the price elasticity of demand. So let's go through the simplest example we can possibly imagine in the universe. Suppose here's our demand curve, and suppose we start off at a price of 8, and at a price of 8, suppose we have a quantity demanded of 110. Then suppose the price in this market rises to 12, and then the quantity demanded falls to 90. Okay, so our sets there are 8 and a quantity of 110, and then 12 and a quantity of 90. Well, we calculate elasticity as the percent change in quantity demanded relative to the percent change in price. Okay, so here the change in quantity demanded is well, so furthermore, that will be the change in quantity demanded relative to the quantity demanded initially, and then the change in the change in price relative to the price initially. Does that make sense? That's just how you calculate percent change, the change relative to the initial value for each of those items. So then the change in quantity demanded is 20 relative to the initial value of 110. And then the change in price was 4 relative to the initial value of 8. If you do the little bit of math here, that comes out to 18% change in quantity demanded relative to a 50% change in price. That gives you an elasticity of 0.36, an elasticity of 0.36. And that's it. I mean, elasticities are just, there's no unit attached to them. It's just, that's what the elasticity is. I mean, again, the elasticity is defined as the percent change in quantity demanded relative to the percent change in price, as you see written up here, but there is no unit attached to the number. The elasticity is what it is. In this case, air good that we're talking about here, that we're depicting, it's inelastic in demand because the elasticity is less than 1. Okay. Now this is called, what we did here is called the initial value formula. The initial value formula, because we based the percent change calculations on those initial values of 110 and 8. There's also something called the midpoint formula. I'm not going to go into it. I'm not going to spend time in this lecture going through it. It's depicted in the book. It's right there in the book. Just follow along in the book. But on the exam, on the quiz, whatever, I'm going to have you calculate elasticity using the initial value formula. That's straightforward enough. I want to use one simple illustration here. How does a change in price affect total revenue. Again, I will just note, I realize that I'm scribbling that, and I realize that looks terrible. I mean, my writing is terrible. It has been, and it's never going to change at this point. But I'm not going to worry about that because you're supposed to have my notes right in front of you, and you can see that written out in type in my notes in front of you. So I'm not worried about the fact that it is chicken scratch because it's right there in front of you. So we're going to look at two different examples here. So over here's the relatively inelastic example, and here's the relatively elastic example. Relatively inelastic example, relatively elastic example. We're going to assume that we start off at a price of 4, and the price of 4 gives us a quantity demanded of 100 in either case. I'm not quite drawing these to scale, but that's okay. Price of 4, in either case, we get a quantity demanded of 100. But then we assume the price rises to 5. Over here, the quantity demanded falls down here to Q2. And over here, quantity demanded falls down here to Q2. Doesn't matter what that new quantity is. So think about this. Now this area depicts revenue gained to the firm. Revenue gained, because for all these units that the firm is still selling, they're making this much more money on each of those units because they're charging a higher price. But this, well, and let me depict it over here too. This is the revenue gained. I'll do this in red. But this area depicts the revenue lost because the firm is no longer selling these units. Right? I mean, we have two competing things that we have to worry about here, right? I mean, the price has gone up. Just suppose you're a firm and suppose you're just charging this price. Don't worry about competition or whatever at the moment. You're making more money on each unit, and that's depicted in the blue section, but you're selling fewer units, so you have foregone revenue after the price rose on those units that you're no longer selling. Okay? I mean, my graph doesn't look great here, so I would suggest that you look at the graph in the book because it probably looks better than the one I've scribbled out. But what you can see here is that the revenue loss section is going to be much larger over here in the relatively elastic case, and the revenue loss section is much smaller here in the relatively inelastic case. And of course, that makes sense given that the demand here is more responsive. So, the question is, the firm raised prices, and was that a good decision for the firm or not? Right? Because again, they're making more money on each unit, but they're selling fewer units now. It's going to be much more likely to backfire, right, in this scenario. Right, much more likely to backfire in this scenario because this section that depicts the revenue lost is much larger in that scenario. So, and there's a lot more you can do here. There's actually, you can do a lot of calculations on whether it would be a good decision or not to raise price. Like if you have market power, when you're looking at the demand of your customers, there's a lot more that we can do here, but all we're just doing is using this concept of elasticity to illustrate how raising prices is going to be much more likely to yield gains in overall profits or overall revenue from this perspective, the relatively inelastic perspective, it's going to be much more likely to backfire with this perspective over here, with the relatively elastic demand curve. So that's it. I mean, this is a relatively short chapter. There's not a whole lot to it. That's the concept of elasticity of demand. Throughout this whole microeconomic section of the course, we will we'll be kind of using these concepts as we go along. It's kind of a nuts and bolts, plain vanilla concept, but we'll use it consistently as we go along, the concept of elasticity of demand. And there are other elasticities as well. And one elasticity that we kind of think about a lot is, or we don't think about it a lot, but we can use it to illustrate income elasticity. Income elasticity of demand. We said before how, for normal good, if income goes up, then demand goes up. Income elasticity of demand will be calculated as the percent change in quantity demanded relative to the percent change of income for the consumers in the market, right? It's the same thing. It's a concept that relates to how responsive demand is to a given variable, but here a variable is just simply income rather than price. No big deal, same concept. Of course, if this is, this is going to be positive or negative based on whether this is a normal good or an inferior good. Another one is the cross price elasticity of demand. Here, what we're talking about is the percent change in quantity demanded. Same idea, we're still looking at how responsive demand is for a particular product, but now we're looking at the percent change in price of another good. Percent change in price of another good. So if the price of Pepsi goes up, what happens to the quantity demanded for Coke? If the price of peanut butter goes up, what happens to the quantity demanded for jelly? If this cross price elasticity is positive, if it's greater than zero, then the goods are substitutes. If it's less than zero, then the goods are complements. That's consistent with what we said before in the demand chapter on those determinants of demand. But we can kind of get a sense of, they're substitutes or they're complements, and to what extent do they move together? How closely does the demand of one good move in response to a change in price of another good? That gives you a sense of kind of the degree of substitutability or the degree of complementarity. If this elasticity, of course, is exactly zero, then the goods are just simply unrelated goods, and it would be really boring to even have this discussion. You wouldn't be talking about the goods in that case. But if they're greater than zero, substitutes. If they're less than zero, complements. So that's it. This is a straightforward concept. There's not a whole lot here that we have to worry about. But we just have to have this concept of elasticity in our back pocket as we go through the rest of the course, because we're going to refer to this over and over and over again in many examples. All right. Hope you all are great. Talk to you soon.